Welcome to The Explainer. Today we're going to be diving into an invisible force that connects something as simple as a magnet on your fridge to the most spectacular light show on Earth. And yeah, it also powers pretty much every moment of our modern lives.
So what is it? I mean, it sounds like a trick question, right? But the answer is one of the fundamental forces of the universe. It's the engine of our world, and trust me, by the end of this, you are going to see that connection crystal clear. All right, so to really get our heads around this invisible force, let's start with something we've all felt in our hands.
You know, we've all played with magnets, right? You feel that weird invisible push and pull, but this isn't some kind of random magic. Nope, it's pure physics, and it's governed by some very specific, very unbreakable rules.
So the first 2 points, you've probably felt those yourself. Opposites attract, likes repel. But that one is really fascinating. If you take a magnet and snap it right in half, you don't get one piece that's a North Pole and another that's a South Pole. No way. You just get two brand new, smaller magnets, and each one has its own north and south. It seems like you can never, ever have a single pole all by itself. So this invisible field, that's the magnet's zone of influence. It's the region where its force can actually be felt. You can almost think of it like an aura of power surrounding it. But here's the kicker. As we're about to find out, physical magnets aren't the only things that can create one of these fields. And this, right here, brings us to the discovery that literally electrified the entire world. It revealed that two forces we all thought were totally separate were actually just two sides of the very same coin. For centuries, electricity was all about sparks and shocks, and magnetism was just about picking up bits of metal. They might as well have been in completely different universes. But then, one very simple observation changed everything we thought we knew. And that is the crucial point, right there. A moving electric current, literally just electricity flowing down a wire, it creates its very own magnetic field. All of a sudden, these two forces weren't separate anymore. They were connected. They were unified into one single thing, electromagnetism. Okay, so if electricity can create magnetism, what can we actually do with that knowledge? Well, as it turns out, we can do quite a lot. This idea led to some truly world-changing inventions.
Think about it for a second. If an electric current has its own magnetic field, what do you think happens when you put that current inside another magnetic field? Well, the two fields push and pull on each other, and you get force. You get motion. And if you can make that happen in a consistent spin, well, you've just invented the electric motor, the engine behind everything from your kitchen blender to a high-speed train. It is a perfect, elegant transformation. You put electrical energy in, and useful physical motion comes out. That simple principle right there is what drives our modern world.
Okay, so we can turn electricity into motion. But physics, it loves symmetry. So can we do the reverse? Can we turn motion back into electricity?
The answer is yes, absolutely. If you physically move a wire through a magnetic field, you can actually push the electrons along that wire. You can create a current. And that is a dynamo, or what we would now just call a generator.
And there you have it, the beautiful symmetry of electromagnetism. It's a perfect two-way street.
This elegant inverse relationship is really the engine of our entire civilization. We use generators, spun by wind or water or steam, to turn motion into electricity. Then we send that electricity down wires, sometimes for hundreds of miles. And then we use motors to turn it right back into useful motion wherever we happen to need it. It's amazing.
So, this force clearly powers all of our technology, but its influence is so much broader than that. Electromagnetism interacts with the very fabric of our world, from the materials we can touch to the entire planet itself. So it turns out not everything reacts to a magnet like a paperclip does. Ferromagnetic things, like iron, yeah, they're strongly attracted. But other materials, and this is wild, like water or even the air around us, are what we call diamagnetic. They are actually weakly repelled by a magnetic field. The force is tiny, for sure, but it's a fundamental property of matter itself.
And this brings us full circle, doesn't it? Right back to that first question. How in the world do we get from this tiny force that can push a water molecule away to the most incredible spectacle in our skies? This absolutely breathtaking display, this kind of celestial ballet in the sky, it's not just beautiful. It's planetary-scale electromagnetism in action.
So how does it actually happen? Well, just imagine charged particles constantly streaming from the sun. We call it the solar wind, and they're just slamming into Earth's huge magnetic field. That field, our planet's own invisible shield, it funnels all those energetic particles down toward the north and south poles. And when those solar particles finally collide with the atoms in our atmosphere, they excite them, causing them to glow, and that glow is the aurora.
From the quiet hum of a tiny motor to the silent dancing lights at the top of the world, electromagnetism is a powerful reminder that some of the most important forces shaping our lives are the ones we can't even see.